exponents and radicals. So before we get started, I just wanted to let you know that you have to check the description periodically if you want to see any updates to any questions or any like extra tips I decide to add over time. Also, for this chapter, I want to go over the formulas first, the formula sheets for exponents and radicals, and then let you know that there were 2 errors that I caught if you have an earlier version of this book. I did fix it, but sometimes it takes a couple days to update, and some people have already ordered it. So the 2 things are that number 23, and pause this if you want to wait till the end to see what the issue is for number 23, and that would be E is the answer. That's the issue, the key. I just accidentally put B for some reason. And then for number 27, there's an issue with the question right over here. So the issue is with the answer choices, and the question. So this is supposed to say 1/3, not 2/3. And then C should be just this instead, like no exponent in there. So now let's go over the equations, the formulas in chapter 4 for exponents before we get started. Chapter 4, give me 1 second, guys. Okay, here we go. So on page 48, we have the exponent rules right over here that basically just tell us about like the stuff like product rule, quotient rule, that sort of thing. So product rule says that if I have 2 things with similar bases or like bases like the x's right here, we add the exponents. So like let's say I have x to the 5th times x to the 4th, and these could be numbers too. I could have like 3 to the 5th, 3 to the 4th, as long as it's the same thing for where what's in place of x. All this says is when you're multiplying between those like bases, you add the exponents. So it's going to be x to the 9th because we're adding those exponents. Now over here, when you're doing division between like bases, like we have here, like let's say you have x to the 5th divided by x to the 4th, and you could use a fraction bar to show division, or they could use an actual division symbol. What you're going to do is you keep the like base, and again, this could be like 2 to the 5th, 2 to the 4th, like as long as it's the like base right there in place of x. What you're going to do is you're going to subtract the exponents. Sorry if we hear that every so often. My poor dog has kennel cough right now, so that's what that is, but she'll stop in a second. So it would be x to the 1st power, which is just x. Hi, Chloe. It's okay. It's okay. Okay. She'll stop in like 1 second. So then we have the power to a power rule, which says that if we're taking the power to a power, we can just multiply the exponents. So it would be x to the, let's say, 2nd power cubed. What we would do is just multiply the exponents. So it would be x to the 6th. And then we have this right here where we have like 2 different bases all raised to 1 power. So let's say you have, let's just use xy. It could be other letters too. Xy to the 3rd power. And actually, let's make it x squared times, I'm going to rewrite that actually. We're going to make this x squared y to the 3rd, all to the 3rd power. What you do there is it's kind of like power to a power rule, but you just have to remember that it goes to each of them. So sometimes what people do is they forget about like one or the other, and they'll only give the 3 to like the y or only give it to the x, but it has to go to both. So it's going to be x to the 6th and then y to the 9th because you're just multiplying the powers for each. Okay, and then, sorry again, my dog has kennel cough. Chloe, it's okay, it's okay. She's getting worked up because the front door just opened. So then we have something to the 0 power is equal to 1. That's always going to be true. And then anything to the negative exponent, like let's say you have x to the negative 2nd power, you just put a 1 in the numerator and you put the thing to the positive version on the bottom. No, it's my poor dog. She has kennel cough. And then, so let's go to radicals right over here. So with radicals, this one is the one that people get wrong, I would say, the most often. And it's basically just if you have 2 different things on the inside, like let's say you have, I don't know, the square root, and it could be like the cube root, the 4th root, whatever, but let's just say square roots in this case, because that's the one that people mess up the most. You have the square root of 2x times the square root of x. What people do is, because they're so used to doing like root 2x times root 2x and then you cancel out the square root, is they cancel out the square root when they're not the same. That's not something you can do. So you have to always remember that when you have something like this, you have to just keep the radical that's involved, in this case a square root, and you're multiplying on the inside. So this is just 2x times x inside the radical, so it would be the square root of 2x squared, and then you could take out the x, and it could be x root 2 in that case. And then for this one, let's say that you had, I don't know, let's do cube root, or actually you see these most often with square roots. I'm going to just keep going with the square roots. So let's say you have the square root of, I don't know, 2 over the square root of 3, we'll say. And that could have also been written as the square root of 2 over 3, and then you can turn it into this. Either way, they mean the same thing. So you could turn it into the square root of 2 over the square root of 3, and then remember that if you have a radical on the bottom, you have to get rid of it by multiplying by it on top and bottom. So this would become the square root of 2 times 3 over 3, and then that would just be square root of 6 over 3. And then for this one, this is just the fraction to an exponent rule. So basically, just remember that if you have, like, let's say, the cube root of x squared, that if you want to turn that into a fraction exponent, it's going to be x to the 2/3, because it's the numerator is the number that it's raised to on the inside, and the type of radical it is the bottom number. So if you have a square root, like let's say you have the square root of x, that would be x to the 1/3, because it's being technically raised to the 1, we just don't write it. Or sorry, 1/2 is what I mean. 1 over 2, because it's a square root, so the radical is technically like the squaring type of radical at 2. We just have to remember that, but all the other ones have them written on the outside. Okay, so now that we've done that, let's go to, and starting chapter 22, the radicals chapter, and exponents chapter. So what we're going to do is, for number 1, the expression right over here is equivalent to, so we're doing equivalent expressions. So I'm going to say, okay, how can I manipulate this equation? So we just learned that we have the same radical right here, the cube root, and when we're multiplying those, we would just multiply them under the cube root right here, so it would turn into this. And then if we keep multiplying that, it becomes 4, and then it would be the cube root of 4x squared. And then this one's a little bit weird, because if you're just trying to simplify it the normal way, you would think, oh, this should be an option over here that I can use, but it isn't. So you have to think of a more unique way to simplify it. So what you need to do is say, okay, what else could I do? Well, I could go backwards. It's not always saying simplify. It just has to be equivalent. Equivalent doesn't mean simplify. It just means equal. So this could be like the step after something else that could be equal to it. So if we go kind of working backwards, we could say, okay, how could they have taken out that 4 there? Well, they could have said 4 times 4 times 4, that's going to be equal to 64. So there must have been a factor of 64 inside the radical for them to have taken that out. So 64 times 4x squared. And then we could say that this is the cube root of 64 times 4 is 256, and then x squared over there. So then that would be A. Someone asked where they can get a book like mine. This book is mine, and it's available on Amazon. It just released like a couple days ago. This is what it's called, Overcoming ACT Math. And all of these get uploaded onto YouTube that I do, because it goes with every chapter is like a lesson. So let's go to number 2. Square root of 81 is equivalent to. So the square root of 81 is going to be equivalent to just 9, because 9 times 9 would give you 81, and there's no like negative on the outside. So it would be G. And then let's go to the next one. Number 3, which of the following is equivalent to all of this? So I start inside out. So I want to start with this inside part, the x squared, and then the fourth degree radical right there. So I'm going to keep the cube root. It is G. A lot of people get confused about this because they're thinking of x squared is equal to 81. That's not what this says. That's a common misconception. They think that it should be H. It should not be. You're thinking of when x squared is equal to 81, you would say it's plus or minus 9. That's not the case here. It's not saying plus or minus on the outside. It's just saying what's the square root of 81. So it should just be 9 here. So then for number 3, it's going to be x to the 2/4, and then 2 over 4 because the numerator here is 2 and the outside is 4. It is right. It is right. I'm telling you guys, I know, because I like see this all the time on the exams, and it's something that people always get wrong. When it's x squared, it's equal to 81. That's what they're talking about, the plus or minus thing. That's what people get confused about. When it's just like this, there's no plus or minus out there. They're telling you it's just the regular version, the positive version of root 81, so it equals 9. So then what we're going to do over here is going to be the cube root of x to the 1/2. So then this, remember, we can say is x to the 1/2 all raised to a 1/3. So all of this is raised to the 1/3 on the inside, and we could say that we're just going to do the power to a power rule, and that's going to be x to the 1/6. You could also do this as like 1/2 to 1/2 over 3 if you see it like that. But I think that that's kind of like a backwards way of doing it, because everyone kind of just memorizes that like a cube root of 3 is equal to 1/3. But either way, so you could have also done it as x to the 1/2 divided by 3, but that's kind of a little more backwards than this. So then let's see, that's equal to that one right there. And if we work backwards, we can say that this would also be equivalent, or you can say, I'm going to simplify this to say it's x to the 1/6. It's not h, guys. This is how they do it on the exam. This is how they do it on the exam. Okay, so let's see. X to the 1/6. Wait, someone just said something. Okay, it's 8. Okay, guys, come on. Dude. Oh my gosh, guys. Okay, you guys, fine. If you don't want to listen to me, then that's fine. I don't care, really. Okay, x to the 1/6 is the same thing as this right here, because we're saying it's 1/6. Because the numerator here would be the exponent on the inside. The type of radical is the bottom number, the denominator. Okay, so then we're going to say that this is the cube root of x to the 1/2, because this is a 1 and this is a square root, so it's going to be x to the 1/2. And then a cube root stays on the outside. So now what we're going to do, again, you can just memorize that this is to the 1/3, or you could say that it's 1/2 divided by 3, whichever you think about. I personally think about it as every cube root is always to like the 1/3, and then you put the other stuff on the inside. So then you can multiply the powers, and it would be x to the 1/6, which is the same thing we just saw as all of these. So it should be 1, 2, and 3e. Okay, so let's go to number 4. Number 4, am I Asian? I mean, not really. Technically, Turkey's in Asia, so I'm Turkish, part Turkish. But no, not like, I don't think I'm technically Asian, but okay. So then let's go to number 4, which says 4/3 times 16 to the 0.7. And we're going to say that this is the same thing as saying to the 3/4, because 0.75 is equal to 3/4. So we're going to say 4 to the 3rd times 16 to the 3/4. That way we have it set up in an easier format than having it to a decimal. Okay, so then what we're going to do is we're going to say, how can we rewrite this so we have like bases? Meaning this number 4 and this number 16, we have to make those look the same, look the same for this problem. So this is going to be 4 to the 3rd times 4 squared to the 3/4. And then, because 4 squared is the same thing as 16, I'm trying to write it so that they have like bases. And I can use power to a power rule right here. And I could say that this is 1, this is 2, they cross cancel, or you can multiply it out and simplify, whatever you prefer. And then this is going to be 4/3 times 4 to the 3/2. So now you have like bases, so you can apply the product rule, which says that if you're multiplying with like bases, you add the exponents. So it's going to be 4 to the 3, this is just 3 over 1, so if we want to make it have the same denominator so we can easily add, we would say that this is 6 over 2 is the same thing as 3 over 1. And then we're going to add the other exponent of 3/2. So then this would be 4 to the 9/2. But you'll see that there's not anything that looks like that, right over here because 9 halves is just 4.5. 4.5. Sorry, that's my dog. So 4.5 is not any of these exponents right there. So I have to think, how can I rewrite this? I see there's 2's involved. So with the 2's, if I have 4 to the 9 halves, 4 is the same thing as 2 to the second power. So we have 2 to the second power raised to the 9 halves. And then, yeah, she scared me a bit. Sorry, she has kennel cough right now. But she'll stop in a second. So then it was 2 to the 9th power because the 2's cancel out. So it's going to be J. Yeah, she just has kennel cough. I took her to the animal hospital the other night, and she's getting a little better, believe it or not. So then let's go to number 5. Which of the following is equivalent to the cube root of negative 64 right over here? So we're going to say it's a cube root of a negative. So that means it's basically asking you, like, what number times itself 3 different times equals negative 64? Well, then that would have to be negative 4. A. And then for number 6, it says if b is a positive real number, then this is equal to. So let's start inside out. So remember, the numerator is going to be your exponent right on the inside of the radical, so 24. And then the bottom, the denominator, is going to be the type of radical it is, which is a cube root. And then we're raising that all to the 1/2. Well, we can go ahead and divide 24 divided by 3. That's just 8. So it's b to the 8th raised to the 1/2. And then that's going to be b to the, now we do power to a power rule where we multiply the exponents. 8 times 1/2 is just 4. So b to the 4th, J. So now let's go to number 7. Which of the following is equivalent to the square root of 192? So I'm going to rewrite the square root of 192 in terms of factors. So 192 is the same thing as saying 64 times, that's 64 times 3, yeah. So we could take out an 8 for the 64, because 64 is the same thing as 8 times 8, and keep the root 3. So the first one works. And then let's see if any of the other ones work as well. So let's see, with number 2, well, that one could work if we, let's see. I'm going to break this up into a different set of factors, because if we take out a 4, that means that a 16, oh my gosh, Chloe, it's okay. Sorry, she's doing that a little bit more because my mom just opened the front door, so she's getting anxious. So we have 16 times 12 could give you 192. And then, so 16 times 12, yeah, that works. 16 times 12 gives you 192 as well. So then you could take out a 4 for the 16, and then keep the 12 on the inside. Yeah, sorry guys, that's my dog. She has kennel cough right now, and she has to be quarantined in my room. So the only way I can do these lives is if she's like right next to me, and if she gets excited, she like starts coughing more. So we have just 1 and 2 are the correct versions, so it would be C. So then we have number 8, which says to simplify this. So remember, this is the same thing as root 7 over root 18. So we cannot have a radical on the bottom. I am giving her medicine. I'm giving her 3 different types of medicine and Pedialyte. So root 18 over root 18 is what we're going to multiply by because we don't want that radical on the bottom. We're not allowed to have that. So we're going to say, okay, this is going to be the square root of 18 times 7 over 18. And then we are going to break this up further on the top into different factors. So this is the same thing as 9 times 2 is 18 times the 7 over 18. So then the 9 is just, that's one of our perfect squares that we memorized. So that would just be 3 root 14, because 2 times 7 would be 14 over 18. Then we can divide by 3 on top and bottom. That would be 1. That would be 6, because that's the greatest common factor. So it's going to be root 14 over 6. So it would be H. So then let's go to number 9, which says we have all of this. Which of the following systems of equations could be used to solve for B and C? Okay, so this is power to a power rule. So this says that 4BC has to equal 64. Well, 4 to what power equals 64? Well, that would be 4 to the 3rd. Yeah, 4 to the 3rd. So then BC would have to equal 3, because 4 to the 3rd equals 64. So then let's go to the next part over here, which says that we have like bases, and we're going to use quotient rule because we're dividing in between, which says that we subtract the exponents. So then it would be 3 to the c minus b is equal to 243. Well, 243 is the same thing as 3 to the 5th power. So we could say 3 to the c minus b is equal to 3 to the 5th power, meaning that c minus b has to equal 5 for this to be true. So we're looking for bc equals 3 and c minus b has to equal 5. So that would be b right over here. Okay, so let's go to number 14. Which of the following is equivalent to this right over here? Okay, let me just see really quick. That would be, if we break that into factors, we could say, I'm going to take out the negative first over here, and I'm going to say it's negative of, that's 14 times 14 times 14 times 3, yeah. Okay, so we have the cube root of that. We've broken it up into factors, and it's a cube root, so we have to look for triples, like right here, where we have 14 times 14 times 14. Chloe, it's okay. So then we have 14 that we're taking out, and we have the cube root, negative 14, sorry, that we're taking out, and then we're going to have the cube root of 3 on the inside. And then we're going to say, okay, can we break this up any further? No, so it's going to be H. That's my dog. She has kennel cough. So she is on medicine and she's okay. Hold on. I think I got distracted. Is this, hold on. That's, oh, sorry, that's not H. That's F. Sorry, I got distracted by her coughing. So then let's see. Number 11. Yes, it is F. Sorry, I just got distracted by her coughing. So then this one is equivalent to, let's see, so it's going to be 2 plus root x. This is for ACT, but it could help you with the SAT as well, because radicals and exponent stuff are on there as well. So what we're going to do here is, this is the same thing as saying this. We have it multiplied by itself. And whenever you have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses, we're going to FOIL, which is an acronym that stands for what we're multiplying together. So F stands for multiplying the first things together, 2 times 2, which is 4. O stands for I'm multiplying the outer things together, so root x times 2, plus 2 root x, plus 2 root x on the inside for the inner things multiplied, and the last things multiplied is going to be root x times root x, which is x. And we're going to combine like terms right over here. So then it's going to be, I'm going to just keep it in the same order so people don't get confused. So 4 plus 4 root x plus x, which I see if I just like switch the order would be D. Someone asked, did you give full meds and she still sounds like that? Yeah, because kennel cough, it lasts for like 2 to 3 weeks. So she's like quarantined in my room because we have other animals right now. And she has to take that for 2 weeks. I like rushed her to the animal hospital the other night, which is why I didn't do a live yesterday, because I was like there until like 6 o'clock in the morning from like 1 o'clock in the morning. But yeah, she has all her meds and stuff. It's just going to take her like 2 weeks to get better. Yeah. So, let's see. Someone asked, where did you get these tests from? This is from my new book that just came out on Amazon. It's called Overcoming ACT Math by Sophia Garcia. Okay, so, you don't get why, because we're foiling this. So it's 2 terms with a plus or minus in parentheses, like 2 things plus or minus in parentheses times 2 things plus or minus in parentheses. So that means we have to multiply the first things, 2 times 2 is 4, the outer things, 2 times root x, 2 root x, the inner things, 2 times root x again, and then the last things, root x times root x is just x. Then you combine these, 2 groups of root x plus 2 groups of root x is 4 groups of root x. And then that's the same thing here. It's just they switched the order. Well, I technically wrote this, so I switched the order of how it looks right here. So then let's go to number 12. Number 12 says, what is the solution to the equation right here? Okay, so we're trying to solve it, so we're trying to get x by itself. So that means that we have to move stuff away from the root x situation happening right here. So we're going to move away the 2. We're going to subtract 2 on each side. So we have negative 5/4 minus 2 is equal to, because it's going to cancel out here, negative root x. Well, I can't subtract just a regular 2 from a fraction. When we're subtracting or adding with fractions, we have to have common or like bases, or like denominators, I mean, sorry. So that means that I have to have a 4 on the bottom here. Well, I can do that by multiplying the top and the bottom by 4. So then I'm going to get negative 5/4 minus 8/4 is equal to negative root x. So then we have negative 13 over 4 is equal to negative root x. So we could just cancel out that negative because if we divide by -1 on each side, that's what's going to happen. And then we could say, okay, that means that the square root of x has to equal 13/4. So that means that x has to equal, because to get rid of the square root, we have to do the opposite, which is squaring it. So if we square each side, it's going to be x is equal to whatever 13/4 squared is, which is just 13/4 times 13/4. And we would say, okay, then that has to equal 169/16, which would be j. So let's go to number 13. So I'm finding the solution, which means I'm solving for x, getting x by itself. I'm going to do that by adding 6 to each side. It cancels out right there, and we get x squared is equal to 16. Now here is the situation where you would have plus or minus, because you would say -4 works and +4 works. So this is where it would be x is equal to plus or minus 4e. So then what pen do you use? This is the Papermate gel pen stuff, Inkjoy Gel 0.7. So then let's go to number, oops, I skipped a page. Number 14 over here. So it says we have this and we want to simplify it. I'm glad you guys are enjoying it. So to simplify this, remember, we can't have a square root on the bottom. So this is going to be root 120. I'm going to rewrite it over here, over root 15. And to get rid of that, that square root on the bottom, I have to multiply on top and bottom by it, by root 15 over root 15. So that's going to cancel out the square roots on the bottom because it's the same exact thing. So it would be technically like the square root of 15 times 15, which is just, we take out the 15 in that case. And then it would be, on top, it would be 120, the square root of 120 times 15. So in order to simplify this, I'm going to have to break up the numerator into factors. So I'm going to say, what can multiply to 120? What can multiply to 15 that I can take out? So if I break down 120 into its factors, I could say that that would be 5 times 2 times 5 times 2 is 10, and then 4 times 3 is 12. So 5 times 2 times 4 times 3 gives you 120. And then for 15, I could break that up into 5 and 3. And then I could say that I have 5 and 3 that I could take out. Also, I could take out for the 4, that's a perfect square, so I could take out a 2 as well, because 2 times 2 is 4. So I could say I'm going to take out 2 for the 4. I'm going to take out the pair of 3s. I'm going to take out the pair of 5s. And then I'm going to leave a root 2 on the inside. And then that's going to be all over 15, because I have all of this over 15. So now what I'm going to do is I'm going to say, okay, 3 times 5 is multiplying to 15, so I can cancel that out on top and bottom. So then it's just going to be 2 root 2, so F. So let's see, we're going to do number 15 right now, which says solve for x in the equation right here. So with these, the first thing I would do is I would say I'm going to turn this radical, like I'm going to get rid of the radical right here, the square root, by saying it's all to the 1/2. So 9x plus 3 is all raised to the 1/2 power, because that's like the fraction that we memorize for square roots. Or you could think about it as this is technically all to the first power on the inside, and the type of radical it is the denominator. So the type of radical is a square root, so the 2 goes on the bottom. And that's going to be equal to 27 to the x plus 2. Now what we're going to do is we're going to try to figure out what is a like base that we can use between 9 and 27. How could we rewrite this so it's like something to the same, to a power, and then the same number to a different power. So 9 is the same thing as saying 3 squared. So 3 squared to the, oops, hold on, let me actually rewrite that a little bit nicer. So 3 squared times x plus 3, and then on the outside, we're going to have 1/2, because 9 just turns into the 3 squared part. And we're just copying down everything else. And we're going to say that 27 is equal to 3 cubed, and then we have the x plus 2. And then, so now what we can do is we're going to simplify the exponent. So 2 times 1/2 cancels out. So then it's just 3 to the x plus 3 is equal to 3 to the 3x plus 2. So if these are truly equal, that means that the exponents have to be equal. So that means that x plus 3 has to equal 3 times x plus 2. So x plus 3 is equal to, I'm going to use distributive property to say that this is 3x plus 6, because I'm multiplying the 3 times each term in parentheses. I'm going to subtract x on each side, and that's going to be 3 is equal, to 2x plus 6. And then we're going to say, okay, I'm going to subtract 6 from each side, so that's going to be negative 3 is equal to 2x, and then I'm going to divide by 2 to get x by itself, and I'm going to get x is equal to negative 3 halves. So the answer would be B. Someone asked, is the ACT timed? Yes, it is. You have 60 minutes for the math section, so 1 minute per problem. So let's go to number 16. This says the expression right over here is equivalent to, okay, so I'm going to start with the x portion. So remember the numerator for if you're rewriting this without the radical and as a fraction exponent instead would be that the numerator, the top number, would be 16. And the bottom number is the type of radical it is. So it's a cube root, so the 3 goes on the bottom, and then we're going to do the same thing for y. Y, the 3 would be the numerator, the 3 in here is the top number, the type of radical is the bottom number. So then now I'm just going to simplify this. So I'm going to say, okay, I'm going to simplify x to the 16 over 3. 3 goes into 16 5 times, and then there's 1/3 left over. So it would be x to the 5th power, because it goes in 5 different times. And then it would be that you have x to the 1/3. And then we would have y to the 3 over 3. That's just y to the 1st power is what that turns into. So then we have one of them has a fraction exponent and the others don't. So the ones that have whole numbers as their exponents, we just write over next to each other right over here. The one with the fraction as an exponent is going to turn into some type of radical based on the answer choices. Again, that's my dog, don't worry. And then we have that this is going to be x to the 1/3 is the same thing as saying the cube root of x. Because the 1 is the numerator on the inside, the 3 is the type of radical it is on the outside. So then that would be equal to j. Okay, so let's go to number 17. For the equation right here, what is the solution? Yes, my dog is sick. She has kennel cough right now, so she's quarantined in my room from our other animals. Let's go to number... Chloe, it's okay. So then let's go to number 17 for the equation right here. What is the solution? So I'm going to FOIL out this part right here, because I have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. So we're going to say minus, for the person that is asking if I can go over number 15 again, this will get uploaded to YouTube, so you'll be able to rewind and see it. So I'm going to FOIL this out because it's 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. So I'm going to multiply the first things, x and x together, so that's x squared. And then I'm going to multiply the outer things, negative 5 times x is negative 5x. And then I'm going to multiply the inner things, 5 times x, which is just plus 5x. Multiply the last things, 5 times negative 5, which is negative 25. And then we're going to say that's equal to x squared. Now, negative 5x plus 5x, those are going to cancel out. So then we just have negative of x squared minus 25. So I'm going to distribute that negative, and it's going to be negative x squared plus 25 is equal to x squared. So then we're going to add x squared to each side. That's going to give us 25 is equal to 2x squared. So then 25 over 2 is going to be equal to x squared. So then here we have, again, this is our x squared situation. So that means that we're going to do plus or minus whatever the square root of this is. So x is equal to plus or minus the square root of 25 over 2. Now, let's just focus on the 25 over 2 part, and we can put the plus or minus after. For the root 25 over 2 part, the root of 25 is going to be 5, so it's going to be 5 over root 2, because the root of the whole thing is equal to the root of the individual parts. So, like, this would be the same thing as root 25 over root 2, which is just 5 over root 2. But we can't have a radical on the bottom, so we have to multiply by root 2 on top and root 2 on bottom. So then this is going to be 5 root 2 over 2, and then we could put the plus or minus in front of it again, and then that's going to be answer choice C. What book do you use? This is my book that just released on Amazon. It's called Overcoming ACT Math by Sophia Garcia. This is for ACT Math. Let me get water really quick, guys. Okay, so if you guys want to see it slower, and again, remember these get uploaded to my YouTube channel, which has the same name as my account, AG Tutoring. So then let's go to number 18. This is equivalent to, so let's start simplifying this. So I'm going to start with the x portion. So x to the 8th, remember this is a square root, so to turn it into a fractional exponent, I'm going to say that this is x to the 8 over 2, because 8 is the exponent on the inside, and the bottom number, the 2, refers to that it's a square root as the radical. And then now let's focus on the 20. So for the 20 part, it's going to be 20 over 2, because 20 is the exponent on the inside, over the type of radical it is on the outside, which is root 2, which is a square root, which has a 2 on the bottom. So now we're going to simplify. 8 divided by 2 is just 4, so x to the 4th, and 20 to the 10th power is what this would be, because 20 divided by 2 is just 10. So the one that says that is F. When is what age is ACT taken in America? It's usually your junior year of high school, but people take it at other times as well. And then it's not exactly the same as GED math, but it is very similar. And don't worry about the background noise. That's just my dog. She has kennel cough. I'm sorry, but she has to be quarantined in my room. And I didn't want to skip the live. So then let's go to number 19, which says that we are going to... Hold up, what did someone say? Is in 2, not 20. Oh, sorry. Sorry, I got distracted while I was talking. Oh, wait, hold on. It says 2, not 20. Oh, whoopsies, whoopsies, whoopsies. Hold on. I did something wrong. Hold on. So that's x to the 8 halves. Sorry, I was getting distracted. And then that would be 20 to the 20 over 2. Did I maybe did I just catch an editing error? I think I just caught an editing error, or you guys just caught it for me, so thank you. Yeah, this is supposed to be, it's supposed to be 2 to the 20th power. Not, that's why, because it does say, hold on, I'm checking, yeah, the answer key does say F, so it's an editing mistake. That wasn't supposed to have a 0 on there. I must have just accidentally typed that. So, yeah, I just caught an editing error, so I gotta fix that. Thank you for that. So then, let's see. And I did it again when I was editing. This is why I do it on the lives, because I miss stuff when I'm editing. So then number 19, solve for x in the equation right here. So let's see, we have the cube root of 729. So 9 times 9 times 9, yeah, that's 729. So then 9 is equal to the square root of x minus b. So then what we're going to do now is we are going to say, okay, I have to get the, I'm solving for x, so I have to get x by itself. So I need to get rid of this radical. And the way I do that is by doing the opposite, which is squaring each side, because that would get rid of the square root, because that's the opposite. So then we would get that 81 is equal to x minus b. So then I'm going to get x by itself. So then I'm going to say 81 plus b, because if I add b to each side, that gets x by itself, is equal to x. So 81 plus b. So someone asked, are you a student or a teacher adult? I am an adult tutor. So then let's go to number 20, simplify the expression right over here. So this is going to be quotient rule. So quotient rule says if we have like bases, we subtract the exponents. So we have x to the n plus 4 minus, and then it's going to be n plus 11. Now you have to remember you're subtracting the whole thing, so that's why I put it in parentheses to remind myself that I'm subtracting that whole part. So I have to say, okay, this is x to the n plus 4, and I'm going to distribute that negative, so it's going to be minus n minus 11. So n minus n cancels out, and then now I'm just left with 4 minus 11 for my exponent. So 4 minus 11 is negative 7. So then this, I could check to see if they have it to a negative exponent, but I see right away that they don't. So they probably use negative exponent rule. So negative exponent rule says that if we have a negative exponent, it's the same thing as saying 1 over the whole thing to the positive version of that exponent, which would be k. So let me just fix that really quick. Okay. So let's go to number 21. Number 21 says we have to simplify this expression right here. So I'm going to start with getting rid of the radical, meaning like the little weird cube root bar. and I'm going to copy over everything else. So y to the negative 1 times, this is going to be x to the 21 over 3, because the numerator is the exponent inside, 21, the denominator is the type of radical it is, and that's all going to be over x minus 2, or x to the negative 2, I mean, and y to the third power. So now I'm going to simplify because 21 divided by 3 is just 7. So this is going to be y to the negative 1 times x to the 7th power over x to the negative 2 y to the third. Now, another thing you can remember is that when you're doing fraction bars like this and there's multiplication involved, that you can just, if you have a negative exponent, it's much easier to just remember that you have to flip it to the bottom or the top, like vice versa. Whatever the opposite is, that's where it goes. Or you could do the quotient rule. Like you could say, I'm going to subtract the exponents y to the negative 1 minus 3. You could do that too. But I think it's easier to just say, oh, I remember what negative exponent rule, I can just flip where it goes on the top versus the bottom. So like if it's on the top, it goes to the bottom. So y to the first should be on the bottom now to the positive version. And the same thing with x minus 2, it should be on the top to the positive version. And then it would be x to the 7th and y to the third. I'm just copying those over. So now I can just use product rule on top and bottom to say that I have multiplication between like bases, so I add the exponents. So 2 plus 7 is 9. And then the same thing on the bottom with the y's. 1 plus 3 is 4. So x to the 9th, y to the 4th. So that would be B. So then let's go to number 22, which says that we have this and we have to simplify it. Okay. So, let's see. Oh, wait, hold on. And I haven't been, I didn't put it, for number 18, I didn't mark that on my thing that I need to change that. Hold on. I'm keeping notes at the same time. Number 18, typo. Okay, now we can keep going. So how do I make wrong answers? Because, that's also why it's really hard to edit these books, because, like, I'm doing, like, wrong answers for the, like, there has to be 4 wrong answers and 1 right one, and, like, I know how kids mess up from doing this so long, so, like, I'm doing it by, like, the most common errors I've seen each time, so I have to do, like, it wrong 4 different times, and then the right way 1 time, so, yeah, that's how I do it. I basically do it, like, all the errors that I'm used to seeing on different types of problems from, like, tutoring students all these years, and then, like, that's how I create the wrong ones. And I do record my lives and I put them on YouTube. So then, number 22, simplify the expression right over here. So remember, we can't have a radical on the bottom right here. So we have to figure out how we're going to get rid of that. And I'll answer all your questions as, like, I see them in between problems. Guys, I'm not ignoring you. So what we're going to do is we're going to start factoring this out into, that's just 9 times 9 times 9. 729 is 9 times 9 times 9, which we can break this up into, like, each of the 9s is a 3 times 3. So then, if it's a 4th root, then that means we have to have 4 of them at the same time. So, to take it out, so we have to take out a 3 for these 4 3s that are involved. So it's going to be 9 root 3 on top, and 3, and then we keep these ones right over here inside of the 4th root. So that's going to be 4th root of 9. It's not a bear, that's my dog. She has kennel cough, but she's on medicine, and I took her to the animal emergency room or whatever, so she's fine. But then let's go and let's see. Okay, so now we're going to do 9 divided by 3, or, like, you could think of it as I'm dividing by the greatest common factor. Either way, same thing. So if I divide by 3 on top and bottom, that's going to be that it's 3 root 3 over root 9. Or not root 9, sorry. The 4th root of 9 is what I meant. Okay, so then, hold on, let me get my bearings again, because I just forgot what I was doing. Okay, yeah. So then, now what I'm going to do is, looking at the answer choices, I see that they're writing it in terms of 3s, it looks like. So I'm going to try rewriting it in terms of a base of 3. So this would be 3 times 3 to the 1/2, because root 3 is the same thing as 3 to the 1/2. And then 9 is the same thing as saying 3 squared. So I could say that this is the same thing as the 4th root of 3 squared, which would just be 3 to the 2 over 4, which is just 3 to the 1/2 if you simplify 2/4. These would cancel out, and then I'm just left with 3 as my answer. So it would be J. And then for number 23, over here, we have what is the value of 3x squared. That's what we're looking for. Okay, so we're going to say that if we have the negative exponent right here, we're going to use negative exponent rule and copy everything else. So root 3 over 2 is equal to 2 over root, or not root x, sorry, 2 over x, because it's just x to the negative 1. So all we do, negative exponent rule says that that's just equal to 1 over x, which if we multiply by 2, we get 2 over x. So now I'm going to cross multiply. I'm going to say root 3 times x, or x root 3, same thing, is equal to 4. Now I'm trying to solve for x so that I can plug it in in here to 3x squared. So I'm going to say if I divide by root 3, I get 4 over root 3. Now, you don't necessarily have to like do the times root 3 over root 3 thing right here because you're already going to square it, so you're already getting rid of the radical, so it doesn't really matter. So if I want to find 3x squared, that's going to be the same thing as saying 3 times 4 root 3 times 4 root 3, because x is 4 root 3, so I'm just squaring it and multiplying by 3. So that's going to be 3 times 16, because 4 times 4 is 16. Root 3 times root 3 is 3. So then these cancel out, and I'm just left with 16. So the answer should be E. So then let's go to number 24. And then let's see, this one says if 433 is 17 less than twice the square of a number, then what is the value of that number? So twice the square of a number looks like this. And then we want 17 less than that, and that has to equal 433. And we want to solve for x, this mystery number. So we're going to add 17 to each side to do that. I am going to post, all of these get posted on YouTube. I'm just like behind schedule because I've been like dealing with my dog and everything. And then, so 2x squared is equal to 450. And then that just means we have to divide by 2 on each side. So then it's going to give us, that's 225 if we divide by 2 on each side. And then that means that x squared has to equal 225. So to get x by itself, I mean, you could also just like look at the answer choices and see like which one is the right one that I should plug in and like kind of guess and check if you want to. But the way you would do it without doing that is just to say I have to do the opposite to each side to get it by itself. So then it would be x is equal to plus or minus the square root of 225, which is just, that's 15. So plus or minus 15. So it would be 2 or 3, which would be J. So then let's go to, let me see if I missed any questions. Sorry, I'm trying to make sure that I'm answering stuff as I go. Do integration next live. I'm trying to stick to just the stuff in the ACT and SAT books for now because I'm trying to promote my books since they just came out. But eventually I will. So then let's go to number 25. The expression right here is equivalent to. So we have like bases and we're multiplying between them. So that means we're adding the exponents. So we're going to keep the like base and then we're going to add the exponents together. But you'll see that none of these look like that. That's because what you have to do is you have to turn the 4, or this is the same thing as 4 over 1, into a fraction with a common denominator before you can add it. So we have to say that 4 over 1, to get it to have the common denominator 4, we can multiply the top and the bottom by 4. So then this is going to be n plus 1 over 4 plus 16 over 4. So then now we can add these two fractions together in the exponent part. So it would be n plus 17 over 16. So then that would be, or sorry, not over 4. That's what I meant. Sorry, I was reading this twice on the bottom. So then it would be A. Okay, so then someone asked, does the book have all the foundations of calculus? So the ACT and the SAT don't test on calculus, so it's not going to include calculus stuff on it. The ACT and SAT test up to calculus, not including calculus. And yes, there's a chapter on probability and statistics. So then let's go to the next one right here, which would be 26, simplify the expression right here. So to simplify these, when you have like plus or minus on the bottom with a radical, you just have to do the opposite. So like if there's a plus in front of the radical, you change it to a minus. If there's a minus, you change it to a plus, and you multiply on top and bottom by that. This book is my book that just came out. It's called Overcoming ACT Math. There's an SAT version by the same title, it's just SAT. So, and it's by Sophia Garcia. It's available on Amazon. So then let's go to this one, and please buy it so that I can, because this vet bill set me back a lot. So then let's go to this one right here, and we're going to say we're going to FOIL on top and bottom. So FOIL means that's an acronym that stands for what we need to multiply. So when I say the F in FOIL, that means I'm multiplying the first term, so 2 times 2, which is 4. And then O is the outer term, so 2 times root 2, so plus 2 root 2. I is multiplying the inner term, so 2 times root 2 over there, so plus 2 root 2. And then L is multiplying the last term, so root 2 times root 2, which is just 2. And that's going to be all over, so now I'm going to FOIL the bottom. So it's going to be the first terms multiplied, 2 times 2, which is 4. The outer terms multiplied, which is root 2 times 2, which is just 2 root 2. The inside terms, or inner terms, negative root 2 times 2, which is just negative 2 root 2. And then we have the L for the last terms multiplied, negative root 2 times positive root 2, which is just negative 2. So these are going to cancel out right there. And then we're going to combine these as like terms on top. So 2 root 2 plus 2 root 2, and the 4 plus the 2. So 4 plus 2 is 6, plus 2 groups of root 2 plus 2 groups of root 2 is just 4 groups of root 2, over, and then it's going to be 4 minus 2, which is just 2. So now I'm just going to divide by the greatest common factor on top and bottom, which 2 goes into all of these. So I'm going to divide by 2 here, that turns into a 1, divide by 2 here, that's a 2, divide by 2 here, that's a 3. So then it would be 3 plus 2 root 2. Oops, that's supposed to be root 2. So then that would be H. So then let's go to number 27, which says, which of the following is not equivalent to this? And then, so what we're going to do is we're going to say, first let's determine like which ones are equivalent. Like let's just start turning this into the radical format, which says that the bottom number tells us what kind of radical it is, so it's a cube root, and the top number tells us what our exponent is, so 128 to the first power on the inside, which is just the same exact thing as what I just wrote there, because we don't write exponents of 1 in math. So this is equivalent to this, so it's definitely not C. So then we have to think, okay, which of these is it definitely not equivalent to? It's probably going to be, it's B. I mean, like you can kind of just see that, but I'm going to show you why it's equivalent to all the other ones as well. So for, let's start with, well, let's just start breaking this apart, actually, would be the easiest way to think about this. So I'm going to think, okay, 128 is the same thing as, that would be 2 to the 7th power. So then that would be cube root of 2 to the 7th power. So then that would be, if I turn it into a fraction format, the same thing as A, 2 to the 7/3. So that's equivalent. We're looking for what's not equivalent. So then I have to think, okay, how can I turn it into D and E if you want to like make sure that it's definitely B? So then to turn it into D and E, let's see, for D, it's going to be, for people saying like, for people saying D, remember, it's what's not equivalent, not what is equivalent, what's not equivalent. So then what we're going to do, let's see. So then 128, if I turn that into factors, I could say that that's 16 times 8, which would be 16 times 8, which means you could also turn that into 8 times 2 is another way of saying 16. So this could be 16 is 8 times 2. And then times 8, which is just, that's just 2 as the cube root. So you have two root 8s, or 2 8s inside of the cube root. Sorry, it's hard to like say it correctly the whole time. So this is the same thing as the cube root of all of this, is what I'm saying essentially. Because these are the factors of 128 when you break it up into factors. So then that would be 2 that we could take out for the 8, 2 we could take out for the 8 again, because 2 cubed is equal to 8. So that would be 2 times 2, and then cube root of 2. So that would be 4 cube root of 2, which I believe is one of the answer choices. Yeah, so that's how you prove that that one's equivalent. So it can't be that. So it can't be that because we're looking for what's not equivalent. And then let's see, the other one that we're trying to prove, 2 cube root 16. So you could say that you just have this portion right here, and you just take out the cube root for the 8 part, and then you would have the cube root of 16 left on the inside if you didn't keep going to this portion right here. So that would also be equivalent. So then that's how you prove that it's definitely B. So then let's go to number 28. Which of the following expressions is equivalent to this right here? So first I'm going to combine my like terms on the top. I have 3 groups of root y, so 3 root y over root 3y. Now remember, I don't want to have a square root on the bottom, so I have to multiply by root 3y on top and root 3y on bottom. So when I multiply by that, I'm going to get, on top I have 3 times the square root of y times 3y over, and then on the bottom it's just going to be 3y. So then if I simplify inside the square root, that's going to be 3, I mean, you could simplify in the square root or you could just take it out. I'm going to just take it out actually because there's already a pair of y's right there. So I can already know that I have to take out a y because there's a pair of them and it's a square root. And then I leave the root 3 on the inside, and then I have 3y over here, and then the 3's and the y's cancel out, 3y and 3y cancel out, so then I'm just left with root 3. So it should be f. So then let's go to number 29. So here we have, just because there's variables doesn't mean that this isn't just a fraction divided by a fraction. Thanks for liking and sharing the live, guys. So this is just a fraction divided by a fraction. So we do the same thing we do when we were in 4th and 5th grade and we learned how to divide with fractions. We KCF, keep, change, flip. So you're going to keep this guy right here. You're going to change the division to multiplication, and you're going to flip this fraction on the right to be wz over y. Now we can cross-cancel the w's, and we can cross-cancel one of the y's, and then we're just left with yz times z on top. So that would be y times z squared, which would just be a. So let's go to number 30. What is the value of x in the equation right here? Okay, so we're going to rewrite these to have a common base. So this would be, I think that's 3 would be the common base that we're going for here. Yeah, so then let's first start with, I'm going to turn this into 81 to the 2/3 power, because the 2 is the numerator, because it's the number that it's being raised to inside the radical. The bottom, the denominator, is the type of radical it is, and then that's going to be equal to 243 to the x power. So I can now rewrite 81 and 243 as 3 to some power. So 81 is equal to 3 to the 4th power. So now you have 3 to the 4th power is 81, raised to the 2/3, and that's going to be equal to, so then we're going to have now 243 is also the same thing as 3 to the 5th power. So now we have 3 to the 5th power taking the place of 243, and that all being raised to the x power. So now we can apply power to a power rule to say that this is 3, and then we're multiplying the exponents. So 3 to the whatever 4 times 2/3 is, so 4 over 1 times 2/3 is just going to be 8/3. Is equal to, and then the same thing for power to a power rule here, multiply the exponents, we get 5x. Now for this to be true, that means that 8/3, this part right here has to be equal to 5x. So it's going to be 8/3 is equal to 5x. So that means that we're going to divide by 5 on each side, which is the same thing as multiplying by 1/5. So it's going to be 8/3 times 1/5 is equal to x. So then that's going to be 8 over 15 is equal to x. So then that's going to be g right over here. So now for number 31, it's going to say we have this expression is equivalent to what? So remember, negative exponent rule says that it's the same thing as putting 1 as the numerator and putting the whole thing on bottom to the positive version of the exponent. So 2 plus y to the 150th power. So that would be just d. It's equivalent to d.